Oh, g'day guys. Today we're going to look at rational functions. Now, all they are is simply a function over another function. And what you generally want to do is get this into the form where you divide f by g, and then that will give you a value of a and some value b over some value of x take c. So in terms of when we start looking at asymptote lines, okay, the a value will be our horizontal asymptote line. Our C value here will be our vertical asymptote line, and so that will give you an example of what we're doing now. I just want to go down to a simpler example, and then we'll go through the one that you can see I've written there. Alright, so let's just do this one here. This is obviously my, if we're looking at here, this in fact would be my sort of f function. Right, so this is my f function here. I'll just change my colour of my pen so you can see the difference. So this is really my f, and this is my g function. So if I do a long division for that, so therefore that's going to be x plus 2, and I'm going to divide that by x plus 1. How many times? I just need to get this value to be the same. So you have to times it by 1. And then I take that away, the x is going to be taken away, and I'll be left with 2 take 1, which will 1. So I could rewrite this equation here if I wanted to. That actually works out to be simply 1 plus 1 over x plus 1. Alright, so in this particular case we can say that our vertical asymptote is this value here, so that's going to be when x is equal to minus 1. So whatever makes this equal to 0 on the bottom line. Okay, so if we made that equal to 0, then that would certainly be something that would do that. So obviously if x equals negative 1, then that makes that bottom line 0 and it becomes undefined. Okay, so that's what we're looking at there. Looking at the horizontal asymptote for this, so if we're wanting to do that one there, the horizontal asymptote, that's going to be when y is equal to 1. Alright, so they are pretty easy to do. The idea of doing this is probably to do a sketch of this particular function. So I could simply draw my axes here, right, and my axes there. This is my x-axis, this is my y-axis. I know I've got a horizontal asymptote, that's that label in there, when y is equal to 1. Okay, so y is equal to 1. I know I've got a vertical asymptote when x is equal to, oh sorry, I'll stuff that up. That's not a horizontal asymptote, it's a vertical asymptote. So if I'm going to do this, I'm going to have my horizontal asymptote here, y is equal to 1, and I'm going to have a vertical asymptote over here at x equals minus 1. Alright, so you get the idea. We do a dashed line to represent that. Now, the thing about all of this stuff here is you can go and put this into your calculator and you can graph it. So what I've done is use my brackets, x plus 2 bracket divided by x take 1. And when I graph that, you can see sort of what's actually happening there. So that's obviously going to my asymptote line from below. Really all you'll be expected to do is put these functions into your calculator. So if the idea of dividing this and getting it into this form here scares you, then you don't really have to do this part down here. Alright, so I need to just do a bit of a sketch of that. Alright, so you can see what it's doing. It's doing this sort of shapey thing. Alright, and so we put arrows there to represent that's what it's doing. It's getting close to that line. Alright, and you can actually find these x and y intercepts as well. I'm not going to worry about doing that for this particular thing. What I want to do is, though, I just want to discuss what happens as it gets close to these horizontal and vertical asymptotes. So as x goes to negative 1 from the right, as x goes to negative 1 from the left hand side. right, as y goes to 1 from above, as y goes to, sorry, is that what it is? As y goes to 1 from above, as y goes to 1 from below. Alright, we want to talk about what happens here. So if we look at the shape of our graph, as x goes to -1 from the right, so from the right hand side, from this side, we know that y goes off to plus infinity, doesn't it? Okay, don't need to put the plus there, but you can. As x goes to -1 from the left, we can say that y goes off to -infinity. Now, doing the same thing of obviously when we're going to 1 from above, okay, we could say that, and it's not the y value, it's the x value. What we can say there is our x value goes to 0, and not to 0, from above, x goes to positive infinity, and as y goes to 1 from below, x goes off to minus infinity. Right, so you don't really have to be able to do any more than that with these particular functions. Alright, so this is an example where you've got two asymptotes, one horizontal, one vertical. I just want to go through this other example which I did with my year 12s last year. So rather than rewriting it, I'm just going to go and talk my way through this. So when we're looking at this one here, it's got a function. Okay, I've now done my division, so what I've done there is said, what do I have to times x by to get x squared? Well, times that by x, and that gives me x take 2x, x squared take 2x. I take that away, and that will leave me with 4x there, and bring the 1 down. What I need to look at this first term, okay, so therefore all I'm going to do there is to say, well, times that whole thing by 4, okay, that becomes 4x take 8, take that away, 1 plus 8 is 9, so therefore I can rewrite this as simply x plus 4 plus 9 over x take 2, right? So you can identify obviously that my asymptote here, if I'm looking at my asymptote there for this particular function, I seem to have no highlighter, okay, so for this particular function here, you can see that my horizontal asymptote is this one here, is going to be, in fact, the equation of a straight line. Right, so that's why you can see this is a diagonal line. So it can be a diagonal line, it could be a horizontal line, it doesn't really matter. Right? And then obviously my vertical asymptote there is going to be when x is equal to 2. Right, so that's what's labelled on there. Now graphing that on your calculator, if I just go to my calculator and put that function in, I'm just showing you what you need to do. I'll just turn this other one off, enter, go to this one at the top there, enter. So I've just put it in exactly the same using my brackets, and then when I graph that, that sort of matches what I'm seeing there, but I'm not seeing the top bit. Okay, so if you don't see the top bit, we're expecting something to come down like that. What you need to do is you need to change your window. So maybe if I increase that to 20, increase that one to 20 as well, because the bottom one we can see, it's just the top one we can't, and graph that, and then you can see that that's actually matching, and that would be the line going through there of x plus 4. Okay, so that matches what we're expecting to see. In terms of looking at our discussion bit, right, so what we'd be looking at as x goes to 2 from the right, as x goes to 2 from the left, as y goes to x plus 4 from above, as x plus 4 from below. What happens? Well, if we're going to 2 from the right hand side, you can see that this function goes off to infinity up here, can't you? Alright, so that's y's going to plus infinity. As it goes from the left hand side, you can see this thing's going off to negative infinity. So that matches my graph and what I'm expecting to see. For this line here, as it goes from above, okay, over here you can see that this function's actually going off to positive infinity, and as it's going from below, it's going off to negative infinity. Right, so that's matching with what I'm expecting to see with my rational function. So really we're using our calculator to do all the work. You graph it, you can sketch it from your calculator, and you just need to be realising what you might expect to see. So Technically, you don't have to do this bit over here. That's not required, okay, because you can just graph it. We don't ever expect to see that. But you need to recognise that you can have things that are in the form of a straight line, or it can be a horizontal or vertical line. Alright, so have a go at some of these questions. Certainly do them on your calculator, and catch up with me if you need to ask me any more questions.